bukan jitu, penuh bermisi guru AYU, mencapai misi yang satu, permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Bismillahirrahmanirrahim. Assalamualaikum. Good evening and hi to all the teachers, parents and the wonderful students. So welcome to Pusat Tuisyen Academy YouTuber, a joint venture with IDD Malaysia and Kelab Guru Malaysia with the hashtag bermula percuma and selamanya percuma. So before we proceed, let's begin our session with the recitation of Kitab Al-Fatihah, and for the non-Muslim, please take a moment of silence. Okay, so how is everyone doing today? My prayer is that everyone is in the best of health and ready to proceed with today's class. So let me introduce myself first. I am Madam Rosmaya as your moderator and also a control host for today. I am a Form 6 physics teacher at SMJK Yuhua, Kajang, Selangor. And the most important person today is our presenter, Teacher Nun. So she is from College Matrikulasi Negeri Sembilan. So let us give a warm welcome to our presenter. Okay, so even though there were only two of us here, but do not worry, we will make sure that today's session runs smoothly. So for the record, we are now live on Teacher Nun's channel. So as a sign of support to Teacher Nun for the hard work in preparing today's lesson, so please subscribe her channel and not forgetting to subscribe my channel too. So as usual, the lesson will last approximately 1 hour. So the certificate link and the credit claim link will be given at the end of this session. And remember that you can only use EDD email and MOE email to claim the certificate. So for credit claim, you need to collect 1 letter and 5-digit codes. I repeat, 1 letter and 5-digit codes, which will be announced separately 3 times during our class today. And be sure to follow the class up until the end to get the complete code for the credit claim. Okay, I would also like to remind students to use appropriate language and also use appropriate profile picture if you wish to post comments in the chat box. I'm pretty sure all of the students here are excellent students who will uphold a positive classroom environment. So please give your full cooperation in making this class a lively one. Stay focused, and if you have any questions, please write on the chat box and Teacher Nun will try to provide you with the answers. Okay, hi Chia Yao, Chia Ying. Okay, so we all can see your chats there in the chat box. Okay, so before I pass this session to Teacher Nun, so I will announce the letter and the first 2 digits codes for credit claim. So the codes are A35. Okay, the letter A and the number 35. So without further ado, please welcome Teacher Nun to start her presentation.
Okay, thank you so much, Madam Rosmaya. So hi everyone, how are you? So welcome to our class today. So for today's class, we will continue our revision and exercise. But before that, I want to introduce you the team that we have in the Academy YouTuber. So the first team here is the Physics Pre-U team, led by Madam Rosmaya, which is with us. Okay, and then we have the Mathematics team, led by Teacher Im. And then biology team led by Madam Cikgu Faiza. And also we have the chemistry team led by Cikgu Nun. Okay. And for the perakaunan, then ekonomi perayu team led by Madam Fizi. Academy YouTuber also have apps. Okay, you can download from the Google Play and you will get a lot of education video there for your revision, for your reference. Okay, now for today's class, we will discuss about the mid-semester test past year question from the topic forces and Newton's law of motion. Okay, so as usual, before we go to the exercise, we do a short revision for this topic. So first part, you have learned about the basic forces and also the free body diagram. So there are five forces, five important forces that you're supposed to know. Okay, the first one is weight. Weight is the force on an object due to the gravitational force. The main point is you need to know the direction of each forces. For example, for the weight, always directed downward. For the tension, is the forces acted in the stretched string, wire, rope, or and others. And the condition for the tension when you want to sketch, you're supposed to sketch the direction away from the object along the string. Okay. And for the normal force, is the force that act on an object when the object is in the contact with the surface, with a surface. And the normal force is perpendicular also away from the contact surface, the direction. And for the frictional force, given by the equation of mu n is the normal force, mu is the coefficient of kinetic or static friction. So the frictional force is the force that act on an object due to the rough surface. Only when the surface is rough, the frictional force exerted, and always the direction is always opposed the motion of the object. And for the external force, there are two external force that we consider, which is pushing force and pulling force. So the direction is depends either it is a pushing or it is a pulling force. So I give you a simple example here. If we have two objects and you need to sketch the free body diagram, please take note. I will tell you the rules to sketch the free body diagram after this. But just to show you what is each forces represent. So referring to this diagram, if we have the object M, we want to sketch the free body diagram for object M. Free body diagram we will consider as point object. Okay, and then the forces exerted on the M1 is, the first one is the normal force. Normal force, as I said just now, it is perpendicular to the surface, and there is a weight, so represented by W1 because we have two objects here. And then there is a string, these two objects connected with a light string. So there is a tension in the string, the green color. And we have, because of this is rough surface, so friction force always oppose the direction of motion of the object. Because of M2 is moving downward, so M1 will moving to the right. So frictional force exerted in the opposite direction, which is to the left. And we have the external force, which is in this case, this is pushing force. But when we sketch the free body diagram, the tail of the force supposed to exerted at the same point or at the point object. So because of that, the direction of external force here is in this direction. It's look like it is a pulling force. And for the second object M2, there are two forces on the exerted, which is the tension. And do take note here, the tension, the green arrow should represent by the T, both is T, meaning that the tension in both string is equal. So that's the condition, because of if the T in the same string, if the T is different, the string will break off. Okay. And the weight is directed downward. Another things which is not the forces actually when we sketch the free body diagram is you're supposed to show the direction of motion of the object, which is represented by the acceleration of the object, because we will apply the Newton's law. Okay, so that's the few way how to sketch the free body diagram referring to the forces that you learn. And now what is the Newton's law? Because I said we want to apply the Newton's law, right? So there are three Newton's law, Newton first law, second law, and third law. So Newton first law state that if the object at rest, it will remain at rest, which is V is equal to 0. And if the object is in the motion, the object will continue its motion with the constant velocity. If not, external forces exerted on it. So because of that, the total forces is equal to 0. Total forces equal to 0, meaning that there are forces exerted on the object, but when we sum all the forces following the horizontal or vertical component, total forces is equal to zero. So we see that it is at rest or moving with the constant velocity. Of course, if the sum of forces is equal to zero, if we go to the horizontal and vertical component, both supposed to be also equal to zero. And for the Newton's second law, the definition of Newton's second law is the rate of change of linear momentum of a moving body. And the rate of change of linear momentum of a moving body is directly proportional to the resultant force and in the same direction as the force acting on it, meaning that because of momentum is a vector quantity, so the direction is same direction with the resultant force. And given by this relationship, and from this relationship, we can derive the equation from rate of change of linear momentum. So we can the equation for the Newton's second law, which is sum of forces or the net force is equal to ma. Okay, ma. This part we consider that the mass, when the forces exerted on the body will not change its mass. The mass is not changing, only the velocity of the object. Because of that, the sum from the definition of the Newton's second law, we get the derived equation, which is sum of forces is equal to ma. And for the Newton's third law, Newton's third law states that every action has reaction, which is same in magnitude but opposite in direction. So given by the equation of, we can apply as FAB is equal to negative FAB, where the magnitude of FAB is equal to the magnitude of FBA. Okay, so this is about the Newton's law. Basically, you need to know that five forces and how to apply the Newton's law. So what is the condition or what is the step when we want to solve the problem that relate to the application of the Newton's law? So I just divide into two. The first one is, firstly, you need to sketch a free body diagram. So if you have more than one object given in a free body diagram in a question, so you need to sketch a separate free body diagram for each object. Okay, that's very, very important. And before you sketch the arrow, before you show the forces exerted on the object, we need to consider, doesn't matter how the shape of the object, so we need to consider the object as a point object. And then we sketch all the forces, depends on what forces exerted on the object, as I show in the example just now. And before you apply the Newton's law, you need to identify the direction of motion. That's why I suggest that you show the direction of acceleration. Even acceleration is not the forces, but it is very important because we want to apply the Newton's law later on. So you show the acceleration direction in your free body diagram. Then it's very easy for you to apply the Newton's law because of you can choose the object and the component either x or y, and then you can apply Newton's law depends on the motion of the object. Either the object is moving with the constant velocity, so sum of fx, you will apply the first law, or if the object is at rest, also you will apply the first law. If the object is moving with the acceleration a, you will apply the second law either at the x or y component. And then when you know which law that you will apply, you can write down the equation, the related equation. Okay, where for the to write down the equation, there is a tips, which is the force with the same direction with the motion doesn't matter. Before this, if we consider, remember you learn about the vector quantity. Normally we follow the sign convention, which is to the right is positive, to the left is negative. But in this case, when we apply the Newton's law, we not consider the direction right to the right or to the left, but we refer the motion by acceleration. We refer to the motion of the object, which is showing by the direction of acceleration. Then we can write down the equation where we always assume that the forces same direction with the acceleration will be positive, and then we can solve the component equation that we have write down. So that's overall about what you have learned in the topic of forces and also Newton's law. Okay, now we go to the question. I hope that you have tried to answer the question referring to the link given. Okay, the first question is, a car traveling at 30 meter per second comes to rest at a distance of 60 meter. If the mass of the car is 2,000 kilogram, calculate the constant force that caused the car to stop at that distance. So constant force meaning that we want to find the total forces or the forces exerted on the car. And if you refer to the information given, uh, the hidden information is only one, if I'm not mistaken, which is come to rest. Come to rest meaning that V is equal to 0. Final velocity is equal to 0. Not mentioned in the question, but you're supposed to identify. Okay. And then first we know that to calculate the constant force, we will apply the Newton's because of if you look at here, we will apply the Newton's second law of motion, right? Which is sum of forces is equal to ma. The forces, constant force that exerted on the car cause the car to move with the acceleration a. If you refer to the given information, we do have the m mass here. We want to calculate the f, but we do not have the value for A. But referring to the information here, we can calculate the acceleration, right? We can use the kinematics equation, which is V squared is equal to U squared plus 2AS. And then because of V is in 0, U is 30, you substitute, you will get that the A is negative 7.5. So don't worry if you get the negative value. Because of you, if you read carefully, it states that the car traveling from 30 meters per second come to rest, meaning that the car is decelerate. Okay, so from that, if you calculate the force, constant forces that cause the car to stop is equal to, when we substitute the mass, 2000 kilogram, and the acceleration. So negative show the direction of F, which is same direction with the acceleration, negative 15,000 Newton. So that's the answer for the constant force. This is a very basic, simple question. Okay, sorry, because of I said that I discussed the mid-semester test past year question. Actually, I have rearranged the question following the learning outcome. Okay, I arranged the question following the learning outcome. So I hope that you're not confused if you find number one is not this question, but actually I have rearranged the question so that easier for me to discuss, easier for you to understand following the subtopic. Okay, following the subtopic. Okay, for question number 2, figure 4.6 shows a block of at rest on a rough inclined plane with the angle of 20 degree with the horizontal. By using the Newton's third law, explain the existence of the normal force acting on the block. Explain the existence of normal force. So how you want to explain? This is for a conceptual question. So first, you need to understand what is Newton's third law because you want to use the Newton's third law to explain. So before this, I just highlight Newton's third law state that every action has a reaction force which is same in magnitude but opposite in direction. So that's the Newton's law. So when you want to answer, when you want to explain the existence of the normal force, you're supposed to can identify what is the action and reaction force. So in this case, if you refer the free body diagram, because of the block at rest, meaning that it is not moving, there is no acceleration or acceleration is equal to 0. So this is all the forces exerted on the object and stated that rough inclined plane. So there is a frictional force. We assume that if the block is moving, it will move downward. Okay. So the frictional force exerted opposite direction. Okay. And then if you look at the W, W is directed downward. So if you look at the W, W is not located at the X or Y component, horizontal or vertical component. Because of that, we need to resolve into WY and WX. Okay, now we go back to the question. You need to explain about the existence of the normal force acting on the block. So normal force is the red arrow. So how we explain? So action force. So there is an action force, then produce the reaction force. So our action force is actually the component of the block's weight acting on the surface perpendicularly. So it is referred to WY. Component of block weight is referred to WY because of WY is in the opposite direction with the normal force, which is our reaction force. So you explain about the action force because of this action force, meaning that the weight that exerted on the surface on the block. So the action force, which is a normal force from the contact surface, act on the block P because of the object is on the surface. So because of the weight, the component of the block weight, the normal force exerted on the object with the same magnitude, normal force and the weight. So when you sketch, actually, you if you want to use the free body diagram to explain, you need to sketch the length of the arrow supposed to be equal. Length of the arrow for the normal force and the WY is equal in length, meaning that the same magnitude, but if you look at the direction of arrow, it is in the opposite direction. So that's the way how you explain the normal force by using the Newton's third law. Basically, you need to refer to the definition of the Newton's law, so you know where you want to start your explanation. Okay. So if you have any question, you can ask me in the comment in the chat box. So I will try to provide you the answer. Okay. Now we take a look at the question number 3. So for question number 3, figure 4.5 shows two boxes A and B being pushed over a rough surface. So F push is represent the external forces. Sketch a free body diagram which show the forces acting on box A. Box A. So in the real situation, you can imagine like this. This is only object A because we want to sketch the free body diagram on the object A. So there's a pushing force. Instead of that, object A is on the on the surface. So there is a normal force exerted on the object A, and then the weight of the object A directed downward. And because of the rough surface, so there is a frictional force. Can you guess where is the direction of frictional force? Of course, the direction of frictional force opposes the direction of motion of the object. When the pushing force is push object A, so friction force will exerted in the opposite direction. Okay, and do we have another forces exerted? Take a look at the diagram. A is side by side with B. So when we push A, B will exert a forces on A. Am I right? A exert the force on B, and B also exerted uh, a force on A, same magnitude but in the opposite direction. Okay, because of that, we can write down that the forces that exerted on A, okay, by B, by object B is FP. This is considered pushing force by B. Okay, this is in the real situation if you want to see the real diagram. But if you want to sketch the free body diagram, remember the condition to sketch the free body diagram? First, we need to consider that object as a point object. Okay, so point object, and easy for us if you easy for you if you sketch the horizontal and vertical component because of force is a vector quantity, right? So easier for us. So now, meaning that the first one is the point object, second one the axis. Okay, the third one is the tail of each force supposed to exerted at that point object. So because of that, we go back to the real diagram. Okay, this is the friction force, and then we have the FB. See, FB is here now because we want the tail of the FB supposed to be exerted at the point object, and normal force as the normal force, the weight also, and the push force FP PF push at this direction. Actually, the direction is not changed. The position only because we want to sketch the free body diagram. All the forces supposed to exerted on the same point object. Okay, that's the condition to sketch the free body diagram. You cannot sketch with the body for the top for this topic. For the rest, for other topic, if you want to sketch the free body diagram, it is okay if you want to use the object. All right. Okay, this is just to show you how to apply the step to sketch the free body diagram. Okay, 3 step, right? First is the point object. Second is the vertical and horizontal axis. Just sketch so that you can sketch the forces clearly, correctly. Okay, and then the tail of the forces supposed to be exerted at the same point. Okay, now we go to the question number 4. So for question number 4, a 20-kilogram box is placed on top of 30-kilogram box as shown in the figure. Determine the normal force. Oh, sorry, I not arrange the number of figure. I not arrange because of this is the real number. Okay, this is maybe the question number 2 for the mid semester test. Okay, the past years. All right, so don't worry, but it is still the same figure. Determine the normal force that the table exerted on the 30-kilogram box. Okay, so in this case, we have two box arranged like this. Just now side by side. Ni at the question number 4 is at the top. So to sketch the free body diagram, because of 20 kilogram is on the top of the 30 kilogram, so we consider it is a one object. Okay, it is a one system. It is a one system. So because of one system, we can consider it is as a point object. And to show it is one system, so the weight here is represent M1 plus M2 times G. That's the represent by weight for this situation. So if you want to calculate the normal force, because of it is stationary on the surface, so the equation we need to consider the axis, so only y component here, and we will apply the Newton first law because of the object is not moving upward or downward. And then we get the equation which is, okay, let's say if you want to apply the first Newton's law, in this case, we consider upward is positive, downward is negative if the object is not moving, meaning that we want to apply the Newton first law. So we just follow the normal rules, to the right positive, to the left negative. But if we have the acceleration, then we're supposed to follow the acceleration. So in this case, n is equal to W. We want to calculate the normal force. Okay. So here normal force is equal to, because of M1 plus M2, right? It is a system. So 20 plus 30, it is equal to 9.81. Okay, 9.81 times 9.81. You will get that the normal force is 490.5 newtons. Okay. So I hope that you have no problem. You can understand the solution. Okay, and especially the free body diagram. Without the correct free body diagram, actually you cannot apply the correct answer lah. You will not get the correct answer. So for question number 5, a box of mass M is placed on an inclined plane as shown in the figure 4.3. Okay, use a free body diagram to explain why the box is at the rest on the incline. So why the box at rest? Why the box is not moving downward? So we need to use the free body diagram. So of course you need to sketch the free body diagram. As I said, first is the black point is referring to the point object, and then the axis x and y. So don't if your plane is inclined, leave it inclined. Don't make it horizontal. You will confuse with the weight later on. Okay, so in this case, because of the object is not moving, so a is equal to 0, no direction and no downward or upward. And then on the rough surface, uh, okay, because of it can stay at rest on that plane, so there is of course there is a friction force exerted on the object. Okay, so to use free body diagram to explain why the box is at rest on the inclined plane. So in this case, because of as usual W is not at the X or Y component, so we supposed to resolve into X component and Y component, and then referring to the concept of Newton's law, Newton first law, because of the object is at rest. So first we refer to the X component. So at the X component, Wx minus Fs is equal to 0, or we get the magnitude of frictional force, which is equal to mg sine theta. So the magnitude of frictional force is equal to magnitude of the component of the weight of the block, okay, of the box. Okay, and then at the y component, the n normal force is equal to the vertical component of the weight. Okay, vertical component of the weight of the box. Okay, so we can see that from the free body diagram. We sketch the arrow because of actually we refer to the free body diagram. We sketch the arrow, which is the length of the normal force equal to the length of the vertical component of the weight. Okay, and then the Fs also, the frictional force, because it is represent the magnitude. The length of the arrow is represent the magnitude. So the arrow is supposed to be same with the Wx for the Fs, length of the arrow. Show that because of both of them at the vertical and horizontal component, it is same in magnitude. Okay, same in magnitude by opposite direction, so the object will at rest. So that's the way how actually this is to prove our answer, meaning that there is a value for Fs, there is a value for n which is same in magnitude. But for the direction, you can sketch the free body diagram to show that the length is equal but in the opposite direction. So total forces exerted is equal to 0. Okay. Now we go to the question number 6. For question number 6, a 2.6 kilo, still one object. Okay. After this, we will look at the what happened if you have a system with the two object involved. Okay, for question number 6, a 2.5 kilogram block slide down a rough inclined plane of an angle 20 degree with the horizontal. Okay, at a constant speed u. Take note, here is constant speed u, which is equal to 1.5 meter per second as shown in the figure. Sketch free body diagram and determine the kinetic frictional force. So we supposed to use the free body diagram and to determine the kinetic frictional force. For that case, first we supposed to sketch the free body diagram. So in this case, our free body diagram, because of, okay, take a look here. Why A is equal to 0? Why A is equal to 0? Because of constant speed. Constant speed, even given the value for speed, but for the constant speed, acceleration is supposed to equal to 0. Okay, so this is the free body diagram. Okay, we know that the weight, because of this is inclined plane, the weight is not located at the x or y component. Because of that, we need to resolve to the wy and wx. Normal force and friction force is located at the x and y component, so no problem. So referring to this free body diagram, we want to calculate the kinetic frictional force. So for the kinetic frictional force, referring to the direction of motion of the object, which is downward, even A is equal to 0, but the object is moving downward with the constant speed, right? So the forces, same direction with the acceleration. The forces, the exerted, same direction with the acceleration, we consider positive. So in this case, Wx is same direction with the acceleration, so Wx is positive. But for the frictional force, it is in the opposite direction with the acceleration, it is negative. So because of that, we get the equation of Wx minus Fk. Fk is referred to the kinetic frictional force lah. Okay, the pink color. So it is equal to 0. Why equal to 0? It's supposed to be equal to ma. Okay, but it's equal to 0. That's why we apply the Newton's first law. And then if you want to calculate the kinetic frictional force, Fk is equal to mg sin theta. We just substitute the mass given in the question. The g is 9.81, theta is 20 degree. Theta is the angle between the theta, we resolve the wx. Okay, wx is mg sin theta. Okay, but, am I right? Resolving vector. Okay, this is the first topic. We still use it, right? We resolve vector w at the x component. We get that because of the angle is here. We get the mg sin theta. So because of that, you get the kinetic frictional force is equal to 8.72 Newton. Okay? All right. So I think that before we go to the question number 7, Madam Rusmaya, maybe we want to uh, have a advertisement.
Break. Yeah. Okay, so we have already go live for 30 minutes. And before we take a break, okay, I will announce the third digit code for credit claim. So listen carefully, everyone. The digit is number 0. Okay, I'm gonna say this for second time. Okay, the digit is number 0. Okay, so let us watch an advertisement for the break.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata ganjaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, so welcome back students, and Teacher Nun, you may proceed with your presentation.
Okay, thank you, Madam Rusmaya. So we go to the question number 7. Okay, so a box of mass M is weighed on a spring scale attached to a ceiling of a leaf. The leaf accelerates with constant acceleration A. State the direction of leaf motion when the spring scale read a value that greater than the weight of the box. With the aid of the free body diagram, explain your answer. Okay, So for the question number A, I just sketched the situation how the object is weighed on a spring scale in the leaf. Okay, the diagram is like this. So because of it stated the condition when it said that when the spring scale is referred to the tension in the string, so in the spring, so read a value that greater than the weight of the object. So T is supposed to be greater than W. So we can sketch the free body diagram. In this case, the represent by the tension, we consider it is a tension, and then W is downward, and for the T to be greater than W, the acceleration is supposed to be upward. So to identify the direction of leaf motion, but it said that you need to explain the answer. Because of that, we refer to the y component because we have assumed that the direction is upward. Then the T is greater than W, referring to the Newton's second law, Fy is equal to ma. So we can get the equation which is T minus W is equal to ma, where T is same direction with the acceleration. So T is T minus W. And if you because this is your explanation, referring to the proof equation, T is equal to ma plus mg, meaning that the value for tension or the value for the spring scale, the reading of the spring scale is greater compared to the weight. Okay, because of if T is equal to weight, meaning that T is equal to mg, but we want that to prove that T is greater than W. So here T is equal to mg plus with the ma, meaning that T is greater than W. Okay, so we can say that the direction of leaf motion is moving upward. Okay, and then for question number B, calculate the apparent weight of the box of mass 0.5 kilogram in the leaf if the leaf move downward with the constant acceleration 2.2 meter per second minus 2. So the tension in the string now is equal to the apparent weight. Okay, apparent weight of the box. Because of that, referring to free body diagram, the leaf is moving downward, so A is downward, and then when we apply the Newton's law, because of in this case, because of the leaf moving downward and W same direction with the acceleration, so we write down the equation which is W minus T is equal to ma, and in this case T is equal to mg minus ma, and we have the value for acceleration, we have the value for the mass of the box. We can substitute in the equation. So you will get that, you will get the tension in the string which is equal to 3.91 Newton. Okay, because I want to calculate the apparent weight. Because of the value for tension is 3.91 Newton, meaning that the apparent weight is equal to 3.91 Newton. Okay. Now we go to the question number 8. Okay, start from question number 8. There are 12 questions. So number 8 and until question number 12, if I'm not mistaken, there are two objects. It is the system with the two objects. Okay, take a look at the first system. 30 Newton block, 30 Newton block 1, meaning that 30 Newton is the weight of block 1, is placed on the table, and a 15 Newton block 2. 15 Newton meaning that the weight of the block 2 is connected to the end of the block 1 by a string and through a smooth pulley as shown in the figure 4. The other end of the block 1 is tied to the wall. Okay, so this is the light string. Both is light string. Calculate the normal force acting on the block 1. Okay, before we calculate, as usual, you're supposed to sketch the free body diagram. We even not mention to you because of to get the idea how or what equation that you want to use to calculate the normal force, we refer to the free body diagram. So this is our first free body diagram for the block 1. So there is a normal force. Okay, take a look here. I represent the green color. The green arrow is T1 and the light green is T2. Why? Because of both is in the string. But I label T1 and T2 because both is in a different string. Okay, different string. So we're supposed to label a label with the different symbol. T1 and T2, for example. And then because of T2 is not at the X or Y component, so we need to resolve. So here is T2X and also T2Y. Okay, that's our basic free body. Actually, the basic free body diagram is represented by N1, T1, T2, and W1 only. The resolving tension here, the resolving forces here is only for for the calculation. Okay, it is not considered as a free body diagram. Only the first four forces, N1, T1, T2, and W1. And for the second object, because there are two objects in one system, so we're supposed to sketch free body diagram separately. So for the block 2, the forces exerted is only T1 and W2. Okay, why this here is not T2? Because of, take a look at the diagram. Then the string from block 1 is connected to the same string connected to the block 2. So because of the same string, the tension in the string is equal even the direction is not equal. Please take note about that. Okay, so I represented T1, T1. Now we want to calculate the normal force. Okay, take a look. Because of sometimes we're not sure where we're supposed to start. So you can start with the normal force because you want to calculate the normal force. But take a look at the free body diagram. How the free body diagram can help you. N1. So for you to get the N1, we will apply the Y component, right? So here there are N1, T2Y, and W1. So if you want to apply either any Newton's second law, you need to know the value, the magnitude of the T2. Am I right? Because of here, T2Y is T2 sine 30 degrees. So we have no value for T2. In the question, not mentioned the value for the string here, the string that connected to the wall. Okay, so we need to find first. For you to find the T2, okay, you need to look at the X component. So at the X component, we have T2X. Because of Ty, we know we want to calculate the N1. So at the X component, T2X. So T2X, we can get the T2. But here there are T1. We also no have value, no value for the T1. So how you want to get the value for T1? You're supposed to refer to the second block. Second block, T1 is equal to W2. So for the second block, it is very easy to get T1 right. So your solution will start with block 2. You can see that. This case, if you're familiar, if you always do the exercise that relate to the free body diagram, relate to the application of Newton's law, it is very easy for you to identify where you're supposed to start. If not, your solution will be very, very long. Okay, in this case, because of we have identified, we're supposed to start with block 2 because we want to find the T1 first. So from block 2, we know that it is a y component and a is equal to 0. We will apply the Newton's first law. So we get T1 minus W2 is equal to 0. And because of that, we get the T1 is equal to 15 Newton. 15 Newton for the T1. And after we get the T1, we can calculate the T2 first, right? Referring to the X component of the block 1. Okay, now we go to the block 1. Take a look at the X component. So the object is still stationary at rest because of it is connected with the string to the wall. So we apply the Newton's first law. And in this case, at the X component of block 1, we can write down that T2 is T2X is T2 cos 30 minus with T1. We consider the object is not moving lah. It is okay because of only two forces and both in the opposite direction. And then when you calculate the T2, you will get that T1 just now 15. So we just T1 bring to this side. So it is 15. And if you calculate, you will get that the T is equal to 17.32 Newton. Okay. Take note, our focus is to calculate the normal force. So now we need to refer to the Y component of the block 1. So at the Y component of the block 1, we also, because of the object is not moving upward or downward, so Fy is equal to 0. The equation that we get is N1 plus T2Y. T2Y is T2 sine 30 degree. Okay, and then W1 is downward, so minus W1, it is equal to 0. This is the concept from the Newton's law. And then substitute the value because we want to calculate the N1. So T2 we have calculated here, 17.32, just substitute in the equation. And W1 is referred to the given weight, which is 30 Newton. So because of that, we get that the N1, if you calculate, you will get that N1 is equal to 21.34 Newton. Okay, so can you see even N1 at the Y component, it is look like that easy to do the calculation, but you need to start with the block 2. This is how the free body diagram help you to solve the question. Okay, So now we go to the question number 9. For question number 9, there are two objects here on the inclined plane. So object P of mass 4 kilogram placed on the inclined plane attached to object Q with the mass of 2 kilogram by a string through a frictionless pulley. When released from rest, a 9 Newton constant frictional force act on block P because of this is rough surface. So there is a frictional force. First, you need to sketch and label two free body diagram which show all the forces that are on the block P and Q. Because there are two objects, so you're supposed to sketch two free body diagram. So our first free body diagram is for the object P. So as I said, this is step by step. Consider that the object P is a point object. So you do a note dot there. And then inclined plane is our axis now. Inclined plane represent x axis and the vertical component is y axis. So the axis, if you look at it, it is not horizontal. It is following the inclined plane. And then we sketch all the forces exerted on the block P. First, normal force, standard at the vertical component, weight is downward. So because of that, weight is not located at the x or y component. And then tension in the string is away from block P. And friction is opposite direction of motion because of A is the object is moving downward. So F is to the positive x direction. And for the WP, because of that's actually the first, this four forces is your free body diagram. Okay, I just add on. This is not your free body diagram, but I add on for the calculation because of WP is not located at the Y or X component. So we need to resolve the WPY and WPX. Okay, so the basic free body diagram is represented by the first four forces. Okay, and for the object Q, there are two forces only exerted, P and WQ. And of course, you can show the direction of A, which is downward because of the object is moving. When released, it moves downward. Okay, that's the free body diagram. Now we want to calculate the acceleration of P, A. We can calculate acceleration. Okay, so how? We refer to the object Q first because of object Q only two forces exerted. So, and instead of we want to calculate the acceleration, we have no value for tension. So referring to object Q, if you, same thing, if you do not know where to start, okay, you can start any object, you can find any info that you can get any extra info from the concept. So for the object Q, which is at the y component only, we get that the object is moving downward. So we apply the Newton's second law. WQ, same direction with the acceleration, minus with T is equal to MQA. And if when you substitute, because we have no value for T and also we have no value for A, we can consider this is our first equation. Because we want to calculate the A, but we have no value for T. Okay, now to find another equation, we can refer to the object P. So for the object P, of course, because of this T is related with this T that is on the object P, so we get the second equation for the object to find the A from the object P, which is, okay, take a look here, T plus WPX. Okay, take a look here. WPX and T is same direction with the acceleration. That's why both is positive. And friction force is in the opposite direction. That's why minus F. So it is equal to MA, because of the object is moving with the acceleration A. And then substitute the value inside the equation, rearrange the equation and substitute the value. So you will get the second equation for tension, which is 4A minus 10.62. This is the second equation for tension. And the purpose is to calculate the acceleration of P. So acceleration of P and Q is actually equal. So don't worry, we can apply both object. We can use both object. So when we take a look at the equation 1, which is equal to equation 2, meaning that because of both is the same tension, so 19.62 minus 2a is equal to 4a minus 10.62. So you get that the A acceleration of the block P, acceleration of object P is equal to 5.04 meter per second minus 2. Okay? So that's the way. Normally, to calculate the acceleration, to calculate the tension, you're supposed to form two equations. And that two equations supposed to be from two different objects. Okay, from two different objects. Okay. Now we go to the question number 10. So for question number 10, two masses M1 3 kg and M2 is 10 kg are connected by a light string, which passes over a smooth pulley as shown. Calculate the acceleration of the system and tension in the string. See, we need to calculate the acceleration, and in this case, luckily, we also need to calculate the tension. And this is quite special because of the object is hanging like this. Okay, there is no surface in contact. So referring to the because of M2 first moving downward, so I just refer to the object M2. So for the object M2, acceleration is downward, tension is upward, W2 is downward. We can apply the Newton first law because of uh, sorry. We supposed to apply Newton's second law because of the object is moved with the acceleration a. Sorry, this here is supposed to be sum of Fy is equal to ma. That's why we get that W2 minus t because of W2 same direction with the acceleration. So W2 minus t is equal to ma. Okay, and substitute the value, you will get the first equation. So for the first equation, um, 98.1 minus 10a. That's our first equation from object 2. Okay, now we can get another equation from object 1. So in this case, object 1 is moving upward. So if object 1 moving upward, take a look our equation. This same lah. We apply the Newton's second law. Sum of Fy is equal to ma. Okay, please do the correction here. So the equation is t minus W1 is equal to ma. T same direction with the acceleration. Now t minus W1. You can compare with the object M2. W2 minus t because of W2 same direction with the acceleration. But for the object 1, W1, tension same direction with the acceleration. So because of that, we get the second equation. And referring to the second equation, you can calculate the acceleration of the system first, which is we make the equation 1 equal to equation 2. You will get the acceleration is equal to 5.28 meter per second minus 2. And then when you get the acceleration, of course, you can calculate the tension, right? So tension, you can choose either you want to substitute in the equation 1 or you want to substitute A into equation 2. Doesn't matter. So I choose equation 1 for example. When I substitute A as 5.28, I will get that the tension is equal to 45.3 Newton. Okay. So that's the way how we calculate the acceleration and tension for this system. Alright, now we go to the question number 11. So question number 11 is quite different with the previous question, even it is more than one object, but the arrangement of the object is side by side, and we need to calculate the acceleration and also the magnitude of the contact forces. So referring to the question 11, three blocks are in contact with each other on a frictionless horizontal surface as shown. Horizontal force F is applied to M1. Okay, so that's the external force lah. So given M1 is 3.25 kg, M2 is 4 kg, and M3 is 5 kg. F is 30. The external force is 30 Newton. So you need to calculate the acceleration of the system. So to calculate the acceleration of the system, of course, the free body diagram first. You also need to identify the acceleration direction. So in this case, because of this is the pushing force, okay, so acceleration is to the right lah. We consider the same direction with the pushing force. Okay, so the black arrow is represent the external forces, and there is a normal force exerted and also the W. And then take note that is stated it is a frictionless horizontal surface. Frictionless horizontal surface too meaning that it is a smooth surface. For the smooth surface, there is no frictional force exerted on the system. Okay, so these three objects, M1, M2, M3 is considered as one object, one point object because of it is located side by side. Okay, in the figure. So referring to the x component because of A, we also choose x component because of this is the component of acceleration too. We will apply the Newton's second law, sum of fx is equal to ma, and in this case f is equal to F is the force exerted at the exponent is only one, which is the external force F. Okay, so this is F equal to M because of this external force push M1, M2, M3 to move with the same acceleration A. So we need to consider all the masses in the system. That's why we do it M1 plus M2 and M3 times A. Okay, now you can see clearly, you can get the value for A, which is 2.4 meter per second minus 2. Okay. And how about the magnitude of contact force between block M1 and M2? Of course, same with the previous question, if not mistaken. M1 and between M1 and M2, there is a force exerted, meaning that M1 exerted on the M2 and M2 also exerted a force on M1. So we want to find the contact forces between block M1 and M2. Okay, contact forces between the block M1, contact force between block M1 and M2. So how? In this part we need to specify. We just refer to because of the force is exerted on the M2 block M1 and between M1 and M2. So our free body diagram now is take note that for you to remember the tail of the forces supposed to exerted at the same point. So this is the external force, pushing force, and F12 is the force between the block M1 and M2. Actually, the direction is it is okay because of the magnitude is same. Okay, the magnitude of the forces is same exerted on the block M1. Because of that, the X component, okay, the object is moving with the acceleration A. So F same direction with A. So F minus F12 equal to M1A. Okay, we consider on the object M1, yeah? And then F is equal to 30, the external force. F12 we want to calculate. M1, the mass of M1 is 3.5 kg as given in the question. And the acceleration, M1 also move with the acceleration 2.4. So we just substitute 2.4 here. You will calculate, when you calculate, you will get that the magnitude of contact force between the block M1 and M2 is 21.6 Newton. So this force, with the same magnitude, F12 and F21 is same magnitude but opposite in the direction only, which is applying the third Newton's law. Okay. Now we go to question number 12. Okay, if I'm not mistaken, this is our last question for today. Okay, take a look at the diagram. Shows that the block P and block Q on the frictionless plane connected by a cord or a string passing over a frictionless pulley. So this is smooth surface. Both is smooth surface. If the mass of P and Q are 100 kilogram and 50 kilogram respectively, you need to sketch the free body diagram for block P only. Okay, referring to the question. And you need to calculate the acceleration of the block. Okay, now the free body diagram for block P. So take note, block P. So I'm sure that you can imagine the first important thing is block P is as a point object. The second thing is the axis is inclined. X-axis is inclined, which is perpendicular to the y-axis. And then all the forces that exerted on the object P, the tail is supposed to be at the point object. Okay, now because of a normal force and the weight, okay, take note at the weight is always downward. And there's a tension, so there's a green arrow here. Because of it is a frictionless plane, so there's no frictional force. Okay, but uh, okay. Now my question is, can you guess why I show the direction of A? The direction of A is downward. Why the direction of A is downward? Okay, because it is not mentioned in the question, but in my free body diagram, the motion of the object is downward as shown. Why? Take a look. Compare the mass of P and Q. P is 100 kilogram and Q is 50 kilogram. Of course, P will cause the object to move downward. That's why acceleration is to that direction. Okay. So referring to this free body diagram, of course, as I said, basic free body diagram is these three forces, but for the calculation, you're supposed to resolve WP. Why we need to resolve the WP? Because of WP is not at the X or Y component. So we supposed to, when we apply the Newton's law, we supposed to refer to the same component. Okay, we resolve to the X and Y component. And to calculate the acceleration of the block P, acceleration of the both block lah, both of them, the acceleration is same. So for block P, take a look at the X component here, X component. Because of it is moving with the acceleration A, so it is equal to MA. We apply the Newton's second law. And to write down the equation, WPX, same direction with the acceleration, so WPX is positive. So WPX minus T, in the opposite direction T, is equal to MPA. And then substitute WPX. WP is mg, and the M is 100. For the P, mass of the object P is 100. So 100 G sine 30 degree minus T is equal to MPa. Okay. And then we just leave it the G there. So when we calculate, we get that the T is equal to 50 gram because of this is sine 30, 100 sine 30 is equal to 50. So 50 minus 100A. We just substitute mass of the P. So we get the first equation. Okay. And then because of we have no value for T. Now to get the answer, to get the second equation, we need to refer to the second object. So for the second object, this is the free body diagram. So I hope that you have no more problem with the free body diagram, especially for the object Q, because of for the object Q, the tension is opposite direction with we resolve the WQ to the X and Y component. So the direction of motion is upward in this case because of P pull it the downward. Okay, and then referring to the X component of the block Q, we get the equation which is T same direction with the acceleration. So T is positive. T minus WQX is equal to MQA. So T, when you calculate, you will get the second equation after you substitute. And the mass of Q is 50. Do take note here, 50 kilogram. When you substitute, you get the second equation. And to find the acceleration, equation 1 is equal to acceleration to equation 2. And then you will get that the A is equal to 0.654 meter per second minus 2. So now you can calculate the acceleration of the block referring to these two equations. Oh, I hope that that's it. That's it for this class. Okay, this is the final question. So I hope that for the Newton's law, you're supposed to familiar because we will use free body diagram. We will apply Newton's law also in another chapter, especially the free body diagram, especially the resolving vector. Make sure that you're expert in that so that you will know where you will have no problem in the next topic. All right. So that's it for today's class. Thank you everyone for joining our class today. I wish you all the best. I wish you good luck. Don't forget to subscribe. And also, if you have any comment, you can comment in my video so that I can improve my next presentation. Okay, thank you so much, everyone. I give back to Medurus Maya. Okay, thank you.
Okay, with God grace, we have reached the end of today's session. Okay, so congratulations to those who are able to follow our session from the beginning till the end. Okay, if all of you, please stop posting your comments for a while. And if you haven't clicked the subscribe button, please do so. Make sure it turns to grey color, not the red color. Okay? So before we end our session for today, I will announce the fourth and the fifth or the last 2 digits code for credit claim. Okay, so listen carefully. The digits are number 9 and 6. Number 9 followed by number 6. Okay. So if you find the today's session, our lesson today was beneficial, click like and share to your friends on your social media. Spread and share the goodness. Okay. Don't forget also to activate the icon bell so that you don't miss the next class session. Okay, every Sunday. Okay, so once completed, type done on the chat box before the certificate link and the credit claim link are given as a token of thank you for your dedication in joining free online class today. So I will paste the link now. Okay, then the link for CGL. Okay. And the last one is the presenter link. Okay. Okay, so the certificate link and the credit claim link already given in the chat box. And please take note, the link will end half an hour after this live. Make sure to use the EDD email or MOE email only to log in. Incorrect email used will not be entertained. If you haven't got one, please apply So the link to apply the e-didik email also given already in the chat box. If you wish to get more comment on the online classes, go to www.academyyoutuber.com. And to those who haven't joined e-didik Junior Telegram, please do so. So once again, I would like to thank all of the students for joining today. Okay, remember that the more classes you join, the more credit you can claim. And feel free to share this free tuition class to your friends and teachers all over Malaysia. Okay, thank you too for being a YouTuber Academy supporter too. So I think that's all for now. Okay, see you in another session. Ingat hashtag bermula percuma, selamanya percuma. And Assalamualaikum. Stay safe till we meet again next week on the same day, same time on Sunday at 5 p.m. Okay, bye-bye.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata ganjaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.